Composing different trigonometric functions. So what if we want to compose trigonometric functions, and one is, say, the inverse of cosine, and one is the sine function. And so we no longer just have our nice pairs of cosine inverse and cosine, or tan inverse and tan. And so if we want to mix it up, we're going to look at how to do that. So in this example, it says, evaluate the expression or state that it is undefined. Do this without the use of a calculator. Part A is sine of cosine inverse of the quantity -1/2. So in this case, I recognize -1/2 as a cosine value from the unit circle. And so I'm going to kind of take the easy road if it's there. So I'm going to draw the unit circle, and I'm going to draw the angle. Now, I have cosine inverse of -1/2. So cosine inverse only has outputs between 0 and pi. So I kind of go find that region. And then where is cosine equal to -1/2 in that region? I say, that is happening at the angle 2 pi over 3, because this point here is -1/2, root 3 over 2. And so since I have a cosine value equal to -1/2 at an angle in between 0 and pi, then I'm good to go. So that tells me that I have sine of cosine inverse of -1/2. The cosine inverse of -1/2 is 2 pi over 3, so this becomes sine of 2 pi over 3. So do I have 2 pi over 3 on my unit circle? Well, yes, of course, that's how I just got this. So what is the sine of 2 pi over 3? Well, the sine of 2 pi over 3 is just the y-coordinate at that point, which is root 3 over 2. All right, now do I recognize 1/3, sorry, we're in part B now, tan of sine inverse of 1/3. Now, do I recognize 1/3 as like a unit circle sine value? No. So this one's a little trickier, but it's still doable. So the first thing I'm going to do is draw a circle, but I'm going to say this is not necessarily the unit circle, which will just give us a little bit more freedom and kind of nicer numbers to work with. So draw a circle here. And I know that sine inverse of 1/3. Okay, well, sine inverse is only equal to values in between -pi over 2 and pi over 2. So I'm just going to kind of highlight that section here on my circle. And now if I have sine inverse of 1/3, I know that sine inverse of 1/3 is equal to some angle theta. Okay, I don't know what that angle is, and I don't need to necessarily find it right here either. So sine inverse of 1/3 is equal to theta. If I have that, I know first that theta is has to be within -pi over 2 to pi over 2. Okay, and then the sine of theta would have to equal 1/3. Well, if sine of theta equals 1/3, then if I'm choosing between quadrant 4 and quadrant 1, because those are my options for an angle equal to sine inverse of 1/3. If sine of theta is 1/3, then my angle must be positive. So I must be living in quadrant 1. And so I'm just going to draw something where I have sine of theta is equal to 1/3. Now, if that is the case, let's remember, if I'm not on a unit circle, then I know that, so like kind of previously on Math 112, sine of theta is equal to y over r. So I'm going to say, let y equal my 1 here, and let r equal my 3. And so I have sine of theta. So here's theta. And then I have some corresponding point, xy. And so how did I get here? I said sine inverse of 1/3 is equal to theta. Theta has to be between -pi over 2 and pi over 2. Now, since sine of theta is equal to 1/3, right, inverses switch inputs and outputs, then 1 must be equal to y, and r must be equal to 3. So sorry, this should be r. Okay. So then sine of theta is equal to y over r. And that's just what we know by the definition for sine, not on the unit circle. So if that is the case, then I just need to solve for x. And so if I want to do that, then I just take a little triangle, and I'm kind of taking it from, where am I taking it from? Right here. Okay, so this is my angle theta. I already know y. Y is going to be the height of the triangle, 1. R is the radius. That's going to be just the hypotenuse of this right triangle. And then I'm going to solve for x. So I have x squared plus 1 squared equals 3 squared. So x squared is 8. And x equals 2 root 2. Okay, so now let's think about what I have. I got to kind of regroup here. I have tan of sine inverse of 1/3. And I say, well, that's just tan of theta, okay? Because I'm saying that sine inverse of 1/3 is equal to theta. And then if I have tangent of theta, well, what is tan of theta? Tan of theta, I know, is just y over x. Again, I'm going back to my definitions for my trigonometric functions, not on the unit circle. So what is y over x? Well, y, I already said, is 1. And x I just found was 2 root 2. Now I often want to rationalize the denominator. Let's do that. I get root 2 over 4. Let's go to part C. Tan of cosine inverse of negative 3 root 11 over 10. Well, you know we're going to want to draw this. So here's what I know. Cosine inverse of negative 3 root 11. So we're just starting with that inside function, that this is going to be equal to an angle. And that's always the case. Where does that angle, where is it allowed to live? Well, it's allowed to live from 0 to pi because I'm talking about the inverse cosine function. Okay, well, because I'm saying that theta is in between 0 and pi here, then I have cosine of theta is negative 3 root 11 over 10. So I can just switch the inputs and outputs if I'm going from cosine inverse to cosine. Because I've already said that the output of cosine has to be between 0 and pi. Now, if that is the case, this is telling me that the cosine of the angle theta is negative. Well, where does that happen between quadrant 1 and quadrant 2? Well, cosine is only negative in quadrant 2. I found the quadrant where my angle lives. That is like half the battle here. So because I've defined this new variable theta here, I'm just saying theta lives in quadrant 2. Okay, great. What about it? Well, let's say I am on a big circle, and not necessarily the unit circle. Okay, and so what I know is that if I can define this point, like it's x and y, and I can define the radius of this circle, if I have x, y, and r, then I can define my trig functions using x, y, and r. Okay. So I said cosine of theta equals negative 3 root 11 over 10. So what do I know? Well, this is an x value, and this is the r value. Okay, so I'm going to say let x equal negative 3 root 11, and let r equal to 10. All right, so what do I have here? I have negative 3 root 11, and I have, oops, I don't have the y value. I'm going to have to solve for that. But I do have r is 10. Okay, so how would I find that y value? Well, I need to construct a triangle. What would that triangle be? Well, it would be this triangle here. So what would I need for that? Okay, so if I'm constructing that triangle, so again, I'm just constructing this triangle here. Okay, I'm going to draw it a little bigger so I can kind of see what it looks like. It's a right triangle. What is the angle down here? Well, what's kind of cool is it's theta prime, which is just the reference angle of theta. Okay, I'm saying the hypotenuse has a length of 10. I'm saying this length here, which is that kind of horizontal leg, is going to have a length of the absolute value of negative 3 root 11. That's the x value there, but I know that lengths of sides can only be positive. And then I'm going to solve for the y value, which will need to be positive because I'm in quadrant 2. So I'm going to have y squared plus 3 root 11 squared equals 10 squared. So then I have y squared equals 9 times 11 equals 100. So oops, I think I have too many equal signs. I need a plus there. Y squared plus. This gives me y squared equals 100 minus 99 is 1. So y, I have to pick, it's plus or minus 1, but I need positive 1 because I am talking about a point in quadrant 2. So now let's see if I've gathered all of my values. I have an x value, an r value, and a y value. Okay, so I have, kind of starting from the beginning, I have tangent of cosine inverse of negative 3 root 11 over 10. And so I'm saying, well, that's just equal to the tan of theta, and I've introduced theta. And again, it's my introduction, right? It's my variable I made up. It will disappear by the end, and I've shown how it applies, so I'm good to go there. So what is tan of theta? Well, tan of theta is just y over x. So what is y over x? Well, y is 1, and x is negative 3 root 11. Now, that's a little bit gross, but I can kind of clean it up by multiplying root 11 to rationalize denominator. I get negative root 11 over 33. All right, last one. Cosecant of tan inverse of negative 2. All right, so need to draw a circle here, and I know that tan inverse of negative 2 is always equal to some angle, and then I need to know more about that angle. Well, I know it's between negative pi over 2 and pi over 2, and because tangent of theta is negative 2 in this case, then I know that the angle theta is going to live in quadrant 4. So there's theta. Okay. Well, then let's use our trigonometry where we define it on a circle, not necessarily the unit circle, right? Where I have a radius that's not necessarily equal to 1. Well, I can think of tan theta as negative 2 over 1. But what it's the negative sign, I could have negative 2 over 1 or 2 over negative 1. Well, what would make the most sense here? Well, this is y and this is x for tan, y and x. But if I'm in quadrant 4, my y's have to be negative. So, and my x's have to be positive. So I can't have this, and I need this case here. So I'm going to say let y equal negative 2 and x equal 1. Okay, good. Now I need to solve for my r. What am I going to do there? I need to construct a triangle. So my triangle looks like this. And I'm actually going to draw a triangle where my angle here is theta prime. Angle theta is actually a negative angle, right? But inside a right triangle, we can't have negative angles. But its reference angle is an acute angle, so all is well there. All right, what is my x? My x is 1. What is the y? Negative 2. But again, I'm defining a triangle side length, so I say that vertical side length is just 2. I'm finding r, which is just the hypotenuse. So I have r squared equals 1 squared plus a negative 2 squared. So r squared equals 5. R is just the absolute value, square root of 5. And I know that I just keep that a square root of 5. It's not negative because it is the length. Okay, I'm almost ready here. So I have cosecant of tan inverse of negative 2. That's the same as cosecant of theta. Okay, well, I know what theta is. And I just need my x, y, and r. So cosecant is 1 over sine. So instead of y over r, I need r over y. So that's just going to be root 5 over, what's my y? My y is negative 2. So this just becomes negative root 5 over 2.